Question C2. C is for communication. 5 marks question on polynomial functions. Well, here we have a polynomial in factored form, and you need to complete this table where we need to write down name of the polynomial and behavior, number of turning points, number of zeros, and symmetry. Name of the polynomial actually depends on its degree, right? So answer these questions, stop the video for the time being. Once you're done, then you can move on and listen to my answers. Well, name of the polynomial is based on the degree of the polynomial. So let's count the exponents. 3 plus 4, 7, and plus 1, 8. So degree is 8. So we name it as octic polynomial, octic polynomial. So that's the name of the polynomial. And behavior. Now and behavior, number of turning points, and number of zeros. We can find out all these things from the equation itself. But it will be nice if we kind of sketch the diagram. So let's try to sketch it. So let me make a light sketch right in the center of this. So here we have zeros at -3, -1, and at 3, right? So let's say these are our zeros. This is at -1, this is at -3, and this one is at +3. Correct? Now these zeros are of different order or multiplicity. So the 0 at -3 is order 1, right? This is of order 4 at -1, and the one at 3 is of order 3. Correct? Now let's also consider the leading coefficient. What do you think is the sign of leading coefficient? We are not really worried about the magnitude or the value of leading coefficient, but sign is important to sketch our graph and answer these questions. Here it is positive, x, here it is positive, to the power of 4 will always be positive, but here it is negative. Negative to the power of cube will be minus. Do you see that? So if you multiply these, the leading coefficient will be of degree 8 but negative, right? So we have a negative leading coefficient, correct? Since the leading coefficient is negative, how is the end behavior? End behavior is right side down, right? So it is right side down. Now, since the degree is even, both will face same side. That is how the graph is. Now we can connect and then do. Now from here, let's start from left to right. Now, the one at -3 is of order or multiplicity 1. So we are going to cross it like this, like a straight line. The one at -1 is of order 4. So once we are here, we have to turn flat. It bounces back. And this one at 3 is of degree or order 3 or multiplicity 3. So it will go like this, right? Now we can connect them. So I'm just making a very, very light kind of a graph so that, yeah, that's how it is, right? Now we can answer all our questions. Well, since we know leading coefficient is negative, let me write an is less than 0, right? So that means an is negative. And behavior, as you can see, as x approaches -infinity, y approaches -infinity, and as x approaches +infinity, y approaches -infinity, both sides. Do you see that? It's an even degree function, so it will face on the same side. Number of turning points you can count: 1, 2, 3, that's it, right? It turns once, twice, third times, right? This is not a turning point, right? 3 turning points. Otherwise, you can also find turning points from number of zeros. Number of zeros are number of factors, which are 3, right? So number of zeros are 3. So number of turning points are number of zeros -1 plus even number of turning points. Do you see? That means 3 minus 1, number of zeros minus 1, plus even number of turning points. We have got 1 even number of turning points. So that is it, which gives us 3 minus 1 is 2, 2 plus 1 is 3. So we get the answer even without sketching, but we can count 1, 2 and 3. Do you see that? So we have 3 turning points. Symmetry. It does not show any symmetry, right? So so we say no symmetry. So that's how it is. Okay, we'll have one more question like this, and then I think it'll be a good practice for you. Thank you.